you guys. Today we're going to be looking at an integral that can be a little confusing on how to attack for some people, and we're going to discuss that kind of. So we have, this is the original question here. Is the integral of tangent cubed of x times secant cubed x dx. And we know that when you're trying to do things with odds, you usually want to get rid of it and make it like an even. So we have tan squared x, secant squared x, tangent x, secant x. Now we also know that this is the derivative of secant x, right? So we kind of know where to go with here. We got to make all of these secant somethings. So just a little review here, just to kind of save time on a test kind of thing. It's something so that you don't have to like freak out during a test. If we have cosine squared plus sine squared of x equals 1, and think of this as all squared, because it's like a squared plus b squared equals c squared. Just the 1 squared is 1. So if we divide by cosine squared of x on each one, we then get 1 plus tangent squared of x equals secant squared of x. And that's why we only have to memorize cosine squared plus sine squared equals 1. So I can rewrite this as secant squared of x minus 1 times secant squared of x times tangent x secant x dx. Now we can do a u sub and make u equal to secant x and du equal to secant x tangent x dx, which is the same thing, I just multiplied them in the opposite order. So we can change this to u to the fourth minus u squared, right? Because it's the same as its derivative property, right into here. And then we have tangent x secant x dx, which is just going to be du, right? And now that's just a regular polynomial integral that I'm sure you guys can do. And you just plug back in the u and the du. Yeah. Adios, amigos.